So how will you find the center of pressure of the same plane surface? So if we take the plane vertical surface here and the centroid be at G, the center of pressure will be slightly lower than the centroid of the body, because in the upper portion the pressure will be lower, and the bottom portion the pressure will be higher than the upper portion, because as you go down hydrostatic pressure increases. So the lower portion of the body experiences a slightly higher pressure than the upper portion. So the center of pressure naturally shifts downward. So how will you calculate the center of pressure of this plane surface? So you can see this h bar is the distance of the centroid of the body from the free surface, and h star is the distance of the center of pressure from the free surface of the liquid. So in order to find the center of pressure, we will consider a small elemental area dA, which is at a distance of h from the free surface. So the total force dF is equal to elemental force dF is equal to P into dA, where P is equal to rho g, as we have seen that earlier, and dA is the elemental area. So what will be the moment, that is dm, due to this small elemental force about this line, about the free surface? So the df, the elemental force, is acting perpendicular to this surface. So this causes a moment dm, and this moment is equal to df into h. So the total moment is equal to integral of dm, that is equal to rho gh dA into h, because moment is equal to force into perpendicular distance, and total moment will be equal to rho g integral dA h square. But integral dA h square is defined as the area moment of inertia of the body. That is integral dA into h square. So you can replace m is equal to rho g into I0. So according to the principle of moments, we have calculated the total moment by integrating the elemental moment. So according to principle of moments, total moment can also be written as total force into h star, where h star is the distance of the center of pressure from the free surface. So F is equal to rho g A into h bar, we have derived in the last class. So F into h star is equal to rho g into I0. So h star will become rho g I0 by AH bar. So this is the formula for the center of pressure. So according to the principle of parallel axis, I0 is equal to Ig plus AH bar square, where Ig is the area moment of inertia about the centroid, and A into h bar square is equal to area into the centroid, distance of the centroid from the axis, the free surface here. So I0 is the moment of inertia about the area moment of inertia about the free surface. Ig is the area moment of inertia about the centroid, plus A into h bar square.